was endocrine regulation, we talked about the organization of the endocrine system, we talked about hormones, and we talked about prostaglandins. What other system in the body is the endocrine system like?
Nervous system.
Nervous system, right? What's the difference though? What does the endocrine system do? Yeah, it transmits its signal through blood. It releases hormones into the bloodstream, then it's got to wait. So compared with the nervous system, it's what?
It's slow.
Slower, right? But what about the effects of them? They last
Longer.
They last longer. Okay. Now, there's two general categories of glands in the body: endocrine and exocrine. What are exocrine classified as?
Have a duct.
Yeah, exocrine have a duct. Therefore, endocrine are ductless, right? Now, most of them are made out of what's called glandular epithelium, but a few endocrine glands are made up of what? Yeah, neurosecretory tissue, which basically is just the end of axons. Good. Let's talk about the location of some of the major glands. If we start superiorly, what would probably be your most superior endocrine gland? Maybe even a little higher than that.
Hypothalamus.
No, a little bit higher.
Pineal.
Pineal gland, okay, then probably the hypothalamus, then the pituitary, and then what? Thyroid or the backside, parathyroid. Keep going, what would be around there?
Thymus.
Thymus, okay, you keep working your way down. What would you have? Pancreas and
Adrenal glands.
adrenal glands or the suprarenal glands. If you're a woman, you'd have what?
Ovaries.
Ovaries. Okay, if you're men, you'd have your testes. All right, pretty straightforward. All right. We talked about the ways that you can classify hormones functionally. You have tropic hormones. They do what?
They act on one
Actin or other glands.
Yeah, they have. These are
secretions,
hormones that
dormant.
have an effect on another endocrine gland. They cause another endocrine gland to release a hormone. So, like your gonadotropids, FSH, LH, they target the ovaries and then cause them to release estrogen, progesterone. All right. Sex hormones are things that target reproductive tissues. What are anabolic hormones?
Como anabolism, like testosterone.
Yeah, they're hormones that cause your body to build things. And testosterone, growth hormone, those are examples of anabolic. But a better way is by structure. What are the two main categories by structure?
Steroid, non-steroid.
You're either a steroid or a non-steroid. If you're a steroid, what chemical are you based on?
Cholesterol.
Cholesterol. If you're a non-steroid, what are you?
Amino acids.
Yeah, usually amino acids. Maybe one amino acid that's been modified, maybe a few amino acids put together, or even a whole protein, possibly. Okay. And you may even have a sugar group attached to a protein. What's that called when you have that?
Glycoprotein.
It's glycoprotein. Okay. All right. Let's see here. The amine hormones, they're made by modifying either tyrosine or tryptophan. And some examples there are epinephrine, norepinephrine. What are the hormones that are derived from tyrosine by adding iodine to it?
T3, T4.
T3 and T4. How many iodines do you have with T3?
3.
3. How many with T4?
4.
4. Good. All right. Now, when you release a hormone into the blood, is that hormone going to affect every single cell in the body?
No.
No. What's it going to affect?
Target
Only
cells,
places that
target
have
tissue,
receptors
target
for that particular hormone. In other words, quote-unquote target cells. Okay? Now, usually in your body, you don't have just one hormone floating around in your blood at a time. And so when you have two or more hormones, what are the three possibilities in terms of how they interact? Synergism, which means what?
A little bit
Two
more
hormones
together.
cause a greater effect.
Yeah, they work together to cause a greater effect than you would expect otherwise. Okay? Epinephrine and glucagon. Both of those are hormones that raise your blood sugar levels. When they're together, they have a greater effect than you'd expect with just either alone by adding up the effects. What's permissiveness?
A small amount of
hormone.
You need a small amount of one hormone to have any effect at all of another one. Okay? An example there was epinephrine and cortisol. All right? Epinephrine is a strong vasoconstrictor, but you need to have a little bit of cortisol around for it to even do that. Okay? And then the last one is what? Antagonists, right? Those are hormones that oppose each other. Okay, what's a textbook example of antagonistic hormones?
insulin, glucagon.
PTH and calcitonin are one. What else?
Insulin,
and glucagon. Okay, so any hormone pair that has opposite effects would be antagonism. All right, then we talked about the structures. You mentioned steroid hormones and non-steroid hormones. Okay, how does a steroid hormone work on a target cell?
It goes into the
Goes
cell.
straight into the cell.
Yeah,
Regulation activity.
it's very lipophilic or hydrophobic, if you want to put it that way. It has no problem going right through the phospholipid bilayer, no problem going into the nucleus, and then when it's in the nucleus, what does it do?
It attaches to a carrier protein and causes transcription.
Transcription. Yeah, that's right. It goes into the nucleus and it triggers transcription to occur, right? And then ultimately, transcription's followed by what? And then what do you get at the end of that?
Protein.
Protein. So that's how a steroid hormone works. It's actually triggering new proteins to be made. Okay. How does a non-steroid hormone work?
It attaches to a receptor on the plasma membrane.
Yeah, it can't get through the cell membrane, so it attaches to a receptor on the cell membrane, and then you can consider that
Triggers
non-steroid
the
hormone
gene.
as being the what?
First
The
messenger.
first messenger. When it binds to the receptor, it triggers the formation inside of the cell of the what?
Second
Second
messenger.
Second messenger. What's the most common second messenger?
Cyclic A&P.
Cyclic A&P. It's not the only one though. There's cyclic GMP, IP3, inositol triphosphate, and some other ones too. And what happens when it forms that second messenger in the cell? What does the second messenger do?
It
Nothing. That's it. No. What does it do? It typically goes around and it turns on enzyme, which turn on other enzymes, and you get this big cascade of chemical reactions taking place.
Right.
Which acts faster, steroid or non-steroid?
non-steroid.
Non-steroid. It's much faster to just flick a switch and turn on an enzyme than it is to actually go through the whole transcription translation process. That takes time. And it's remember, it's a one-to-one relationship basically with the steroid. As much steroid hormone as you have, that's as much protein that you're ultimately going to get out. Not the case with the non-steroid. It tends to have a cascading effect, so it doesn't take much non-steroid to trigger this big series of chemical reactions that keep expanding, turning on more and more enzymes. Okay? All right. How do you tell, just looking at the name, if you had to put them in categories, how do you tell a steroid hormone from a non-steroid hormone? It ends in ONE or OL. Why don't the estrogens, why does an estrogen end in OL or ONE? Yeah, it really represents a group. And if you go into the individual members of that group, they do end in ONE or OL. So estradiol, estrone, all of those ones are that. So make sure you can differentiate whether something is a steroid hormone versus a non. If you're just playing the odds, what should you choose?
Steroid.
Non-steroid. There's a lot more non-steroid than steroid. Okay. So most of the non-steroid hormones act like I just mentioned. What's the exception to the rule, though?
T3, T4.
T3 and T4. For all intents and purposes, they act like what?
Steroid hormone.
Steroid hormone. All right. Very good. Now, you can adjust the impact that a hormone has on a target cell by adjusting the level in the blood of that hormone. But what's another way that you can also modify the effect?
The number of receptors on the cell.
Yeah, you can take the target cell and adjust the number of receptors that are on that. If you increase the number of receptors, what's that called?
Upregulation.
Upregulation. If you decrease the number, that's
Downregulation.
downregulation. Good. We then moved on. We talked about prostaglandins. Prostaglandins are based on a 20-carbon fatty acid called arachidonic acid. And they're sometimes known as tissue hormones. What does that mean?
They regulate nearby cells within the same.
Yeah, unlike most of your endocrine, most of your hormones do what? They get released in one gland. They go into what then?
The bloodstream.
The bloodstream, and then they're taken someplace far away. Prostaglandins, not the case. They're basically confined to one tissue. You have a few cells releasing it, and they go and they affect their nearby cells. Okay. Now, there were different types of prostaglandins. Prostaglandin A, that's a strong vasodilator, and it causes a drop in systemic blood pressure. Prostaglandin E is a big inflammatory prostaglandin. It promotes inflammation. It's the formation of prostaglandin E that's blocked by what class of drugs? Yeah, ibuprofen, the so-called, do you know what that class, Motrin, naproxen, what's that class of drugs? NSAIDs, non-steroidal anti-inflammatory drugs. Okay. Prostaglandin F, that's an important one for causing uterine contractions, and it's actually, when oxytocin stimulates the uterus to squeeze, it's actually causing increased production locally of prostaglandin F, which helps with the contraction process. Bless you. All right. By the way, people always ask me, are these the questions? These are not the questions. These are just a condensed version of your PowerPoints. Anyway. All right, prostaglandins. Keep in mind, too, some other related chemicals to prostaglandins, thromboxanes. They promote blood clotting. Leukotrienes are sort of chemical messengers that regulate the immune system. Okay. All right, that's it for Chapter 18. Any questions about Chapter 18?
Nope.
Nope? All right.